In the previous video, we talked about compound value, which is also sometimes called future value. And there is a difference between something called future value and present value. And what we're going to talk about in this video is we're going to focus on the present value. But before we go into that, I want to make sure you understand the difference between the two. Now, when we talked about future value before, we talked about a lump sum of money, which I'm going to draw or represent with a box. And then it sat in the bank and it grew into a bigger lump sum of money. So I'm looking at this like a timeline, which I start here and going to the right, I end up with a bigger box, which represents a bigger lump sum of money. Now, when we use table 12.1 in our student handbook, which was the first column with all those values, what we were doing was we knew the starting amount, and what we were doing is we were looking to find out what that bigger lump sum of money was and what it grew to. So when we use table 12.1, that's the situation where we know the beginning amount or the starting amount, and we want to see how much it's going to grow to, which is why I put a question mark in that second bigger box. It's called the future value because we're literally trying to figure out what the value will be in the future. Now, what we're going to talk about in this video is present value. So we're going to do the same thing that we did before, but we're doing it in reverse, okay? So, I'm going to set up a picture where it's like a timeline going from left to right. For present value, that's the smaller box. And that's when we don't know what the starting amount is, but we do know what we want that amount to grow to. So examples of this might be if I am trying to save money for my kid's college fund, and I know when my child turns 18, I want to have $60,000 saved up, and I need to figure out what I need to put into the account now. That smaller lump sum of money that I need to deposit presently, right now, so I have that $60,000 in the future. So when we use table 12.3 in our handbook, that's the second column, that's going to represent present value. So that's a situation where we know what the end result is. We know what we want to have in the future, but we need to figure out what we have to put in the bank right now to have that amount later on. Now, the process is the same for looking up the values on the table. We're just going to use a different column now. So this example says Reen Weaver needs $20,000 for college in 4 years. So she knows what she wants to have in 4 years. She can earn 8% compounded quarterly at her bank. How much must Renee deposit at the beginning of the year to have $20,000 in 4 years? So she's trying to figure out how much she needs to deposit now so she has that $20,000 in the future. So what we're going to do is we're going to still go through the same process. We still need to know what the rate per period is. We still need to know the number of periods. But this time, since we're trying to figure out the present value, we're going to use table 12.3, which is the second column. Okay, so the rate per period, if we look at what it is annually, it says 8%, but it's split up over 4 periods in a year. So we're going to take 8 divided by 4, so the rate per period is going to be 2%. The number of periods, if it's 4 times a year for 4 years, that means it's going to be 16 periods. Okay, so we're going to look in the student handbook. We're going to look up in the corner for the page that says 2%. And then we're going to look down at the periods that says 16, the number of periods. But now we're going to look at the second column for the value. So don't look at the first column because this is present value. We want to look at the second column. When we look at that second column, the table value should be 0.7284. So just like before, we're going to take the amount that's given to us in the problem. In this case, it's the future value, which is 20,000. I'll abbreviate future value times the table factor. I'll abbreviate TF for table factor, which is 0.7284. And that's going to give us $14,568. So what this means is if she deposits $14,568 in the bank currently, under the situation where it's compounded 4 times a year at 8%, then in 4 years she will have $20,000. Okay, the next example says Bill Blum needs $20,000 6 years from today to attend a VPR Tech. How much must Bill put in the bank today to reach his goal if it is compounded semi-annually with 12% interest? So he knows how much he wants to have in 6 years. He needs to figure out how much he has to invest right now in order to have that $20,000 in 6 years. So this is a present value question, which means we're going to use table 12.3. We still have to find the rate per period. We still need to find the number of periods. And we're going to use table 12.3. And we're looking for our table factor. So we know how to multiply. So we know what we need to multiply the 20,000 by. So since this is 12% interest and it's compounded semi-annually, so that 12% interest is going to get split into twice a year. So the rate per period is going to be 6%. The number of periods, since it's twice a year for 6 years, we're going to have 12 periods. So then we're going to look up on the page in our student handbook that has 6% up in the right-hand corner. And then we're going to look for the number of periods, 12, and we're going to go down the second column, table 12.3, and look for the table factor. We're going to get a table factor of 0.4970. So we need to take the future value times the table factor to see what our present value is going to be. I'm going to take 20,000 times 0.4970, and I'm going to get $9,940. So what this means is if he invests $9,940 right now, in 6 years, he will have $20,000. Okay, last example. It says Bob Fry wants to buy his grandson a Ford Taurus in 4 years. The cost of a car will be $24,000. Assuming a bank rate of 8% compounded quarterly, how much must Bob put into the bank today? So he wants to have $24,000 in 4 years, and he needs to figure out what he needs to put in the bank today so he can earn enough interest to have $24,000 later. So we're going to find the rate per period. We're going to find the number of periods. Since this is a present value problem, we're going to use table 12.3. And we've got to look up the table factor. Okay, so the rate per period, since this is 8% compounded quarterly, that 8% is split up into 4 chunks. So this is going to be 2% for the rate per period. And let's see, this is 4 years quarterly. So that means 4 times a year for 4 years. So we're going to have 16 periods. Now, if we look at the page up in the right-hand corner that says 2%, and then we scroll down the second column that says 12.3 and look under 16 periods, we're going to find that we have a table factor of 0.7284. So that means I'm going to take my future value, I'm going to multiply it by my table factor so I can get my present value. So I'm going to take 24,000 times my table factor, which is 0.7284, and I'm going to get $17,481.60. So that's the amount that he has to put in the bank right now, so that in 4 years he can earn enough interest so that he can have $24,000 and buy his grandson a car. So to sum up, when you're reading these problems, all of them pretty much have the same procedure. You're looking for the rate per period and the number of periods. The thing that you have to be very careful of is read the problem so that you know if you're talking about future value or present value, so that you know which column to look in when you're looking up your table factor. So just make sure that you read the problem carefully. You can use the reference sheet that I posted online with these examples here with the boxes to help you determine which table or which column in your student handbook that you need to use.